339. Okay, so today we're talking about what's called the discriminant. And so we've learned a lot of different ways to find the roots or x-intercepts or zeros of quadratic equations. We've talked about graphing, we've talked about factoring, completing a square, and yesterday we talked about the quadratic formula. So now we have 4 ways to solve the same problems, but we know that for some of them there's better ways to do things than others, right? So what we're going to do first is we're going to practice a factoring problem, but it's kind of a different one. So if you want to flip the page to 340, and we'll do example 2 together. So if you get a quadratic equation like this, it's kind of ugly looking, right? It's not at all like we're used to seeing it, but it's actually not too difficult to deal with. So the reason that it looks so ugly, right, is because all of our a's are the denominator, right? And we always deal with them as the numerator. So what we want to do is we just multiply both sides by a squared. Okay? So you do both sides so it doesn't change the equation.
This is Lisa. Please come to the office.
And that'll give us a squared multiplied by 2 a squared plus a squared multiplied by 3 over a is equal to -1 times a squared. As we can remember, right, we know from way back that when we multiply something, we distribute it to everything inside. So that's why we get a squared times 2 over a squared plus a squared times 3 over a. So if we're multiplying a squared by 2 over a squared, we know that our a squareds cancel out. If we multiply a squared by 3 over a, we know that, okay, a squared is the same as a times a. So we cancel out one of the a's from each. And then -1 times a squared is just -a squared, right? So we can rewrite this as 2 plus 3a is equal to -a squared. Okay, does that make sense to everyone, especially this step here? I know that's kind of the trickiest. Okay, and then from here, our factoring isn't all that tough. So we formed a quadratic equation, so we'll just put everything to one side. So we'll go and add plus a squared, and we'll get a squared plus 3a plus 2 is equal to 0. And then this is like one of the very first type of factoring problems we learned about. This is type 1, so we go, okay, what plus what is equal to 3, and what multiplied by what is equal to 2. So we'll go, oh, 2 and 1. Then we can go a plus 2, a plus 3 is equal to 0. We go a plus 2 is equal to 0, a plus 1 is equal to 0, a is equal to -2, and a is equal to -1. Okay? So now there's not really any quadratic equations out there that you can't solve, right? Even if you get something where our x term, or in this case our a term, is part of a fraction on the denominator, you now know how to solve these as well. Okay? So we're going to move on to this part. So this is part of this is kind of like a half review from yesterday. So we'll go, okay, when we have x squared, what does our a equal? I want to put up their hand. No. You have, pardon? Exactly, 1, right? So a is 1, b is -6, and 5 is c. So we go, okay, b squared, negative 6 squared, minus 4, 1, and 5. And we know that that gives us 16 under here, which gives us 6 plus 4 over 2, 6 minus 4 over 2. And so we know that our roots are, this is like 10 over 2, this is like 2 over 2, 5, and 1. Okay, so we can say our roots are 5 and 1. And look, there they are on the graph as well. Okay? So this equation here is a little bit different, but we're going to do the exact same thing, okay? So we have a is 1, b is negative 6, this time c is 9. So we go, okay, negative 6 squared, minus 4, 1, 9. And this one gives us 36 minus 36, so 0. Okay. So this is kind of a special case because now we say, okay, so 6 divided by 2 is 3. 6 divided by 2 is still 3. So we have two roots, but they're both the same. So we know that our graph will look like this, where just the vertex is touching the x-intercept at 3. Okay? And then we'll do this last one quickly. So again, a is 1, b is negative 6, and c is 13. So we go, okay, negative 6 squared minus 4, 1, 13. So if we multiply all this, we get negative 16 under the square root sign. So what does this tell us right here? It's impossible, right? So there's no solution using the quadratic formula. So we say no roots. And if we were to graph it, our graph would look like this. So we can see that there are no roots because it doesn't touch the x-intercept at all. So the key to this lesson, you'll notice, has to do with this. Okay? So if we flip the page over, go down to here. The part of our quadratic formula that's under that square root sign is called the discriminant. Okay? And the discriminant's important because it'll tell us whether we have 1 root, 0 roots, or 2 roots, right? So this was like our first one, 2 and 3. So how many roots did we have with our first equation? Someone want to put up their hand? Yeah, 2. What about our second? 1. And our third we had 0, right? Because it was a negative. And so for the nature of the roots, this is like notes here, so maybe throw a star next to it. You say real and unequal because we have 2 different ones. For our second graph, we say it's real but equal because we had that 6 minus 0 and 6 plus 0 are the same thing, right? Come on. And then for our third one, we say non-real because we can't take a square root of a negative number. So when we have real unequal roots, we say that this is positive, right? Because it's greater than 0. When they're real but equal, it's 0. And when it's non-real, they are negative. Okay? So now when you're doing the quadratic formula, by the time you're done this step, you already know whether you have 1 root, 2 roots, or no roots. So it's another trick to help speed things up. And maybe just write this in quickly because this is excellent study sheet notes. Okay. So if you ever have any questions about where they ask what the nature of a root is, that's when we want to hear the real equal, the real unequal, or the non-real. Yep. Yes, we can. We'll even put it in a different color. Yep. So we'll show some reflections. Perfect. So we'll do some examples together. So on the next page, example 4, they ask us to determine the nature of the roots without solving or graphing. So we don't even have to use the entire quadratic formula, just the discriminant. So we'll still go A, B, and C. So A is 6, B is -1, and C is also -1. So we go, okay, B squared minus 4AC is all we need to do. So we'll go -1 squared minus 4, 6, and -1. Okay? And then we find, oh, that's like 1 plus 24 is equal to 25. So we say, okay, so 25 is greater than 0, so the roots are real, and they are unequal. We have two different ones. Okay, so let's do number 2. Oh. So number 2 is one of those ones where you have to kind of reformat it. So we'll go, okay, x squared minus 8x plus 16 is equal to 0. We go A, B, C. We know that A is equal to 1, B is equal to -8, C is equal to 16. And then the same thing. So we get -8 squared minus 4, 1, 16. Okay. And this would give us 64 minus 64 is equal to 0. So we know that our roots are real and equal because it would just touch that line. And then this one, so we go, okay, A is equal to 5, B is equal to 2, and C is equal to 1. And then we use our handy dandy discriminant. I looked on YouTube for a discriminant song. No dice. Minus 4, 5, 1. So we get 4 minus 20 is equal to -16. So we say non-real. Not for this one, I could graph them quickly. Verify A. Okay. So to verify these, all you have to do is go, okay, y1 is equal to 6x squared minus x minus 1. Graph that. and we can see, oh, we have two roots, one there and one there. Ooh. Okay, so we'll do B really quickly. Okay. So on an exam, you could verify it by graphing it. And if all the question is asking for is how many roots or what the discriminant is, you don't even have to figure out, like, solve for what the x-intercept. If you just test it and say, oh, look, there's one, that's good enough. Do you want me to do it? There. Okay, and then for the last one, y equals 5x squared plus 2x plus 1 plus 1. So, not touching it. Mega notes. Okay. So the next type of question is a little bit more difficult. So it's saying, determine for what values of m the quadratic equation x squared minus 8x plus m has are three different situations. So let's figure out what our a, b's, and c's are. So a is equal to 1, b is equal to negative 8, and c is equal to m. So we put those into our discriminant, and c, and we go, okay, so b squared, negative 8 squared, minus 4, 1, m. Okay, so that gives us 64 minus 4m. And so they're asking us for real and distinct roots. So distinct means unequal, right? So we get to go b squared minus 4ac must be greater than 0, right? Because we know when it's greater than 0, it's positive, and that means we'll get real answers and two different answers. So then we go, okay, so we already figured out that the discriminant is equal to 64 minus 4m. So we can go, that's greater than 0. And then we just want to solve for m at this point. So we'll go, okay, minus 64 from both sides, which gives us negative 4m is greater than negative 64. And then we divide by negative 4 on both sides. And what happens when we divide by a negative with an inequality? Exactly, it switches. Good work. So we'll get m must be less than 16. Okay. So anytime that m is less than 16, we'll know that we get two different roots and that we actually get roots. So for this one, real and equal roots, we already know, okay, b squared minus 4ac is equal to 64 minus 4m. And so we just know that from this here. And then we kind of set it up the same way. Okay, b squared minus 4ac. For real roots that are equal, or only one root, we need it equal to 0. So we just follow the same process. So we minus 64 from both sides, get negative 64, and we get m is equal to 16. So even if you're not given like an equation with normal coefficients, you can figure out when it would have the different types of roots. And so if you had to guess when the roots wouldn't be real, what would you guess just based on this? Yeah, exactly. So for all the YouTubers out there, we'll figure it out. And this time we go, okay, the discriminant must be less than 0. So we get 64 minus 4m is less than 0. And then the same thing. Subtract 64 from both sides. Divide by negative 4. And because we're dividing by a negative, we have to flip the sign. So we get m is greater than 16. So when m is less than 16, we get 2 roots. When m is equal to 16, we'll get 1 root. And when m is greater than 16, we'll get no roots. So no roots, 1 root, 2 roots. Okay? For number 6, this one's kind of tough. They say state a condition for the discriminant so that the equation ax squared plus bx plus c has real roots. So we know real roots, if we look up here, is when we have it greater than 0 or equal to 0, right? The only time we don't have real roots is if the discriminant is less than 0. So we go b squared minus 4ac must be greater than or equal to 0. Okay? Then they say given that the equation ax squared plus bx plus c is equal to 0 has real roots, state a condition so that the roots are rational and irrational. And so you'll remember that rational is like when whatever is under that perfect or under that square root sign we can solve for. And irrational is when it doesn't solve for a whole number and we have to leave it under there. Okay? So for the first one, if it's rational, that means that we can take the square root of whatever is under that square root sign. Okay? And so that just means that everything under that square root sign is a perfect square. And so this is nice to know because if we see that this is a perfect square, we know that our answer is going to be a nice fraction, something that we can work with. If b squared minus 4ac is not a perfect square, that means our answer is going to have that radical sign in it and it's going to be harder to work with. Well, not really harder to work with, but just you'll have to express it as an exact value. Okay? And so, Mr. Trimble, do you usually do C? I was thinking I wouldn't do it. So, the homework for today is 2, 4, 5, 6A, and 7. Okay, so we're skipping around a little bit in the homework today.